Dear students, welcome to s.mathguru classes. So today we start the new topics, application of partial differential equation. We solved some problems about homogeneous, non-homogeneous in the last video. Now we consider this is how to apply the application of partial differential equation. So we consider some problems, how to solve the problems. So this one given applications of partial differential equations, method of separation of variables. First is method of separation of variables. First we consider example. Applying the method of separation of variables techniques, find the solution of the partial differential equation 3ux plus 2uy equal to 0, where ux equal to del u del x and uy equal to del u del y. This problem is given. Now solution is start. So here given 3ux 2uy equal to 0, and this implies 3 del u del x 2 del u del y equal to 0. This is number 1 we consider. We consider this is number 1. But here given u and here x and u here y. So let u equal to capital X of x, capital Y of small y, where x is the function of x only and y is the function of y, small y only. So this one, capital X is the function of x only and capital Y is the function of small y only. This is function of x and this one function of y. So we consider u equal to this. This is number 2 we consider. Differentiating partially with respect to x of equation number 2. Now if we differentiate, now del u del x, this equal to, when you differentiate partially with respect to x, then y is constant. So y is outside, we write del x of capital X. So y is constant, we differentiating partially with respect to x. Again differentiating partially with respect to y. And at that time x is constant, x outside del y of capital Y. We get this. So here del u del x, del u del y given. So from this we find del u del x, del u del y. Now we putting this value in equation number 1. Now 1 implies, we putting the values in equation number 1. In 1, this is 3 del u del x. Del u del x we get y, capital Y, del capital X, del x, plus 2 del u del y. This is x, del y equal to 0. Now this is our variable separation. Del x, here y, this is not possible. Here del y, here x, this is not possible. So dividing both sides by xy. If we dividing by xy, then we get 3y by xy, del x, 2x by xy, del y equal to 0. We dividing both side by xy. So this implies y cancel 3 by x del x 2 by y del y equal to 0. Now this implies 3 by x del x equal to minus 2 by y del y. You get this. This one taking right hand side, you get this, and this equal to k. So say we consider this is k. So what we get? 3 by x del x equal to k, and minus 2 by y del y equal to k we get. And this implies 3x by capital X, this is k by 3 del x. This del x taking this side and k by 3 this. Variable separation del x with x, and we integrate this. If we integrate, then this is log x and this is k by 3 x plus c1, and this equal to x equal to e to the power k by 3x plus c1 we get this one. X equal to, here base is e, so if we remove log, then x equal to e to the power this, because we know this formula, if a to the power x equal to n, taking log on both side, log n base a, then x. If we taking log, then x becomes here n is power of a. So log n base a equal x. Again log n base a equal x. If we remove log, x becomes here n is here. So here base is e. Then if we remove log, then x equal to e to the power this. We get this one. Again this one, again minus 2 by y del y equal to k. This implies del y minus k by 2 del y. So this is y. Variable separation. Integrate this, then this is log of capital Y minus ky by 2, this is y plus c2, and if we remove log, then y equal to e to the power minus k by 2 y plus c2, we get this. So we get the values of x and y. Putting the values of x and y in equation number 2. Now 2 implies u equal to capital X comma capital Y. X y we write, and putting the values of x y, u equal to x means e to the power k by 3x plus c1, and y means e to the power minus k by 2y plus c2. We get this one. This implies u equal to, if base is same, power will be 8, e to the power k by 3x plus c1 minus k by 2y plus c2, and this implies u equal to e to the power k by 3x minus k by 2y plus c1 plus c2, and this equal to u equal to e to the power k by 3x k by 2y e to the power c1 plus c2, and this is u equal to, here taking k common, x by 3 y by 2, here we consider a. So this is u equal to a e to the power k x by 3 y by 2. So where a means e to the power c1 plus c2. So we get, this is our final answer. So answer is this one. So we get, this is our answer, u equal to a e to the power k into x by 3 minus y by 2. This is the final answer. Problem. Very easy. Solve the following equation: del square z del x square minus 2 del z del x plus del z del y equal to 0 by the method of separation of variables. Now solution. So here del square z del x square 2 del z del x del z del y equal to 0. We consider this is number 1. Here z function and x and y, let z equal to x y. This is number 2, where x is the function of x only and y is the function of y only. This. So we differentiate this one with respect to x partially, del z del x. If we differentiate with respect to x partially, then y is constant. We write simply y, no need to write this y, del x del x. But here second order derivative given, again we differentiate. Del x, so y constant, this is outside, del x del x del x. So this will be del square z del x square y del square x del x square. We get this one. Next, del z del y. Del z del y, we differentiate with respect to y. At that time x is constant, x del y, this is capital Y. So putting this value in equation number 1. Now 1 implies this is del square z del x square minus 2 del z del x plus del z del y equal to 0. This is equation 1, and putting the values del square z del x square, we get this one, y del square x del x square, del z del x, this is y del x, y del x, del z del y, this is x del y equal to 0. So putting the respective values, del square z del x is this value putting, and del z del x this one and this one last. So this is variable separation. Here x we get y, here x y, then y x. We dividing both side by x y. If we dividing both side by x y, then y by x y del square x del x square 2y by x y del x x by x y del y equal to 0. After cancelling, we get 1 by x del square x del x square 2 by x del x 1 by y del y equal to 0. So we get this one. Already variable separation is complete. X with x, y with y. Now this one taking on right hand side. So this is 1 by x del square x del x square 2 by x del x equal to minus 1 by y del y equal to k. We consider this one k. So we get this one. So we get 1 by x del square x del x square minus 2 by x del x equal to k, or minus 1 by y del y equal to k. We get this. So this x multiplying on right hand side, del square x del x square 2 del x and this is kx, this one. So this one del square x 2 del x minus kx equal to 0, where del x means capital D, del square del x square means capital D square. So this implies d square minus twice d minus k x equal to 0. We get this. Now auxiliary equation m square minus twice m minus k equal to 0. This is unable to factorize because we don't know the value of k. So if we are unable to factorize, then we know this formula, quadratic formula, ax square plus bx plus c equal to 0. Then x equal to minus b plus minus b square minus 4ac by twice a. We know this formula. Using this formula, this is m equal to minus b means minus 2, b square minus 2 square 4ac by twice a. This is 2 plus minus 4 plus 4k. This is 2 plus minus 4 common 1 plus k, and this will be 2 plus minus 2 root over 1 plus k. So this equal to m equal to, we get 1 plus minus root over 1 plus k, or we can write m equal to 1 plus root over 1 plus k, m equal to 1 minus root over 1 plus k. We get this. Therefore, we get the solution x equal to C1 e to the power 1 plus root over 1 plus k x plus C2 e to the power 1 minus root over 1 plus k x. We get this. This is the solution for x equal to this one. So if roots are unequal, we know this formula, because we know this formula. Suppose roots are m1, m2, then solution x equal to or y equal to c1 e to the power m1x, c2 e to the power m2x. If roots are unequal, then this is the solution. Next, this one again, minus 1 by y del y equal to k, del y by y equal to minus k by minus k del y. So if we integrate on both sides, so log y equal to k y plus we consider c. We consider c, then y equal to e to the power minus ky plus c. So e to the power minus ky e to the power c, and this will be e to the power minus ky. This is C3 consider, where C3 means e to the power c. We get this one. C3 means e to the power c. So what we get? Minus ky c3 we get. Therefore what we get? Y equal to we get c3 e to the power minus ky. We get this one. This is ky. Therefore we get the value of x and y. These two values we get. Now 2 implies, putting this value in equation number 2, 2 implies 2 is we get z equal to x y. So z equal to x means this one, c1 e to the power 1 plus root over 1 plus k x, c2 e to the power 1 plus root over 1 minus root over 1 plus k x into y. Y means c3 e to the power minus ky, and this is the final answer. Z equal to we get c1 e to the power 1 plus root over 1 plus k into x plus c2 e to the power 1 minus root over 1 plus k into x into y. Y means this value, this. So this is the complete solution of the given problem. Therefore these are very easy, very interesting, very simple also, but most important for engineering courses. It may be in third semester or second semester, but these are important. So I hope you are all enjoying with me. If you are all enjoying, then please share this video to other engineering friends also and B.Sc major also, and like this video and click the bell icon. Thank you.